The following video covers the law of cosines. So let's go ahead and take a look and see what it says. Well, it says that in any triangle ABC, alright, and we have a figure right below, we have the following relations. Well, namely, a squared equals b squared plus c squared minus 2bc cosine a. Alright, and then b squared equals a squared plus c squared minus 2ac cosine b. And then c squared equals a squared plus b squared minus 2ab cosine c. So, what we're trying to say here is that if we want to find the side length A, we need to know side length B, side length C, and we need to know the measure of angle A. So that's the way we find side length A, the measure of this right here. Now if we want to find side length B, suppose this part of the triangle, this length right here, well, we need to know A, the measure of A, the measure of C, again there, and then we need to know the measure of the angle, this part right here, the angle B. Okay? And if we'd like to know the length of side C, which this is side C again, we need to know A, B, and then the measure of angle C, which is right here. This angle measurement right here. So it's important to note the pattern that exists here. So notice for A, well, you need to know angle A and B and C. For B, again, you need to know angle B and A and C, the opposites. For C, you need to know angle C and, of course, A and B, the opposites. Or the not necessarily opposites, but the other legs of the triangle, the other pieces of the triangle. So notice the pattern, all right, and that's going to help you determine what it is that you need to do in these types of problems. So let's go ahead and take a look at an example using the law of cosines. In the following example, we're taking a look at something called a side-side-side. So I'm going to go ahead and note that here for you. It's a side-side-side triangle. Why do we call it a side-side-side? Because I have three sides, A, B, and C. Okay? Now it's very important to note the following pattern or relationship that exists. Notice that here is angle A. Well, directly opposite of angle A is side A. Here is angle B, and directly opposite of angle B is side B. And here is angle C, and directly opposite of angle C is side C. So when you're constructing your own triangle, you need to set it up like this. Okay. Now, the first thing we're going to need to do is solve the triangle. So basically what we need to do is find out the measurements of the three angles, A, B, and C. Okay? So when we do that, well, that's fairly easy to accomplish using the law of cosines. So what we're going to do in this case is we're going to use one of those variations of the law of cosines. So I'm going to take a look at the part that says, let's say I want to find angle A first. So I'm going to use the first one that was listed. And it looks something like this. A squared equals B squared plus C squared minus 2BC cosine A. Now, you might wonder, well, we already know A, why do we want to solve for it? Well, the important part to note here is that we're not going to solve for side length A, we're going to solve for angle A right here. So what we need to do is manipulate this formula right here to get this right here by itself. So if you notice, B squared plus C squared minus 2BC times cosine A. Well, I want to get B squared and C squared by themselves. So I need to move these to the opposite side of the equation. So how can we do that? Well, they are being added, so logically what we need to do is what? They're being added, we need to subtract. So let's go ahead and do that. Let's go ahead and subtract that. So I'm going to say, well, a squared minus b squared minus c squared. Okay, I've got that now on one side of the equation. Now, the next part to note is that these things right here, minus 2bc, is being multiplied by cosine of a. Well, how do I get rid of this if this is being multiplied? Well, let me think about that. What is the opposite of multiplication? The answer there is division. So let's go ahead and divide. Okay, so we're going to divide, all right, the left-hand side by minus 2bc. Okay, and that is going to equal cosine of a. All right. Now we've got a squared minus b squared minus c squared divided by negative 2bc, and that equals cosine a. All right. Now we still need to get cosine to the other side. We need to get a by itself because that'll give us the angle measurement. Now, a student might suggest, well, just divide by cosine, which would be nice, right? But in this case, you can't do that. However, we have a trigonometric function, cosine inverse, that we can apply to both sides to get a by itself. So you take the cosine inverse of both sides, and cosine inverse basically gets rid of the cosine. So what I'm going to do is I'm going to apply the cosine inverse to both sides. So let's see here, cosine inverse of a squared minus b squared minus c squared over negative 2bc, and that is going to equal my angle A. Okay? Now, the rest is pretty easy because I just plug in the numbers from up here in the triangle A, B, and C. A, B, C, B, C. I plug them in there and I will find my answer. So let me go ahead and change my pen color real quick. So we're going to plug in those numbers, all right? And it's going to look something like this. Cosine inverse of, okay, so A again is 5. So 5 squared minus 8 squared minus 12 squared divided by negative 2 times b, which in this case is 8, times c, which is 12. Okay, there we have it. And that's going to equal my angle A. Well, I'm going to continue to simplify this. All right. I'm going to continue to simplify this, and let's pick a different color here. Let's pick a blue. All right. And when I simplify this, if I look at the top, I have 5 squared, which is 25, 8 squared, which is 64, 12 squared, which is 144. So 25 minus 64 minus 144. I would do the top part on your calculator and then the bottom part on your calculator. Do it separate so that you have two distinct numbers. Okay, now let's see. Doing so, I get, I'm going to rewrite my cosine inverse again. Alright, on the top I have negative 105. On the bottom I have 2 times 8, which is 16, and then 16 times 12, Well, that's about what? 192. Negative 192. So what I'm going to do next is punch this in on my calculator. Now, if you're using the TI-84, you will hit second and then cosine. And when you do that, you'll see this function right here appear on your calculator. Now, the next thing you do is type in 105 divided by 192. Now, why didn't I mention the two negatives? Because of the fact that a negative divided by a negative is positive. So you really don't need to put these in there at this point. All right. So let's see. We plug this into our calculator, and what would we get? Okay. Well, when you do this, okay, this gives you a number. I'm going to round it to the nearest whole number. So suppose it's about 18. So it's 18 degrees. And this right here equals the measure of angle A. So angle A is 18 degrees right there. Alright? So this is the measure of angle A. Alright? Now, we need to find angle B, so we're going to go ahead and do that next. But I want you to notice, do we really need to calculate all three angles using the law of cosines? The answer is no. We'd calculate the first two, we'd add those, and then subtract from 180 in order to calculate the value for C. So let's move on really quickly. We've got the idea of what we have to do now, and we're going to find the measure of angle B next. Okay, so again, angle A is 18 degrees, all right, and we need to find angle B. So I'm going to use the idea, or not really the idea, but the law of cosines. In particular, the one that states b squared equals a squared plus c squared minus 2ac, right? Cosine of b. Okay. Again, I'm going to manipulate this and refer back earlier in the video how I manipulated this. So I'm just going to write this out for you to speed things up for you. Alright, so I have that right there, and I can state very quickly that b equals cosine inverse of b squared minus a squared minus c squared over negative 2ac. Alright, so there we have it. Alright, and now what we're going to do is plug in the numbers that we know so that we can solve for our angle B in this case. Okay, so let me pick a different color. Let's go with red this time around. Okay, so alright, I'm going to find cosine inverse of, let's see, b squared is 8 squared and minus a squared, which is 5 squared, minus, and then c squared, which is 12 squared, divided by negative 2 times, and then we have a again, which is 5, and c again, which is 12, and we close it off there. Alright, so computing this once more, cosine inverse. Alright, we have 8 squared again 64, 5 squared 25, 12 squared 144. 64 minus 25 minus 144. Okay, I'll give you a second to think about that. Okay, well, it happens to be negative 105. Okay, and let's see. Okay, 2 times 5 is 10 times 12 negative 120. All right. Now I compute that on my calculator once more. Again, you hit second cosine. And since both of these right here are negative, you just type in positive 105 divided by 120, and you'll get your answer. So in this case, the angle here for B equals 29 degrees. So let's fill that in, 29 degrees. All right, so we are almost done with this example. Let's go ahead and work on the very last part of this. Before we get to the very last part of this video, I do want to make note that there is a minor correction, something that I overlooked. I was looking at the wrong part of my notes here. This part right in here should not say 105. Okay. It should, however, say 183 or negative 183 divided by negative 192. So that was a small error on my part, and I do apologize. So please go back and adjust that. Okay, now let's go ahead and get to the very last part of this video. Okay. So here we have 18 and 29 already. So all we need to do is say 180 minus 18 minus 29. Okay, and these are, of course, all degrees. And what's left over is really quite simple, 133 degrees. So I'm going to write in 133 degrees right there. And there are my answers. For this triangle, I have found all the angles. Angle A, 18 degrees. Angle B, 29 degrees. And angle C, 133 degrees. So minus that one minor error, pretty straightforward if you think about it. A really great example for the law of cosines. So good luck with this.
Made with Doodlecast Pro.